How is everybody doing? I'm going to do two problems together. It's like one question with two parts. The reason is because there are similarities and differences between the two questions, and this is like an excuse to explain the concept. What we have is a swimming pool. It's or not necessarily a swimming pool, but it's a pool of water. It's 1,000 meters across and 100 meters up. And what the questions actually say is somebody has to swim to the other side and then walk the rest of the way. And he swims at 3 kilometers per hour and he walks at 5 kilometers per hour. Find the point on the line to minimize the amount of time for the swimming and walking together. And then we need to attach a wire that goes across the pool and then to the far corner. And in the water, the wire costs $5 per meter to build. And along the land, it is $3 per meter to build. Find the point on this other side to minimize the costs. Okay, so here's one diagram. That's 3 kilometers per hour, 5 kilometers per hour. There's $5 per meter, $3 per meter. The point where the swimmer reaches, I called it X, and the point where the wire reaches the other side, I called it P. I used two different letters to avoid confusion. Now what I could do, I could call this X and this 1,000 minus X, or I could call that X and call this 1,000 minus X. I get the same answer. It's not a question of which is correct, it's a question of which is easier. I can see I'll be doing some arithmetic over here. So I put X on this side because it's easier to work with X than 1,000 minus X. Now, as you can see, it's the same diagram using Pythagoras. If that's 100 and that's P, that's the root of P squared plus 100 squared. And same principle with Pythagoras, that's the root of X squared plus 100 squared. It's the same diagram. All right, so I'm going to start in both questions. That we know speed is distance over time, so time is distance over speed, which means the time he spends swimming is the distance divided by the speed. So that's the distance in the water, X squared plus 100 squared rooted, which is the power of half, divided by 3. And the other leg of the journey is 1,000 minus X. So the time he spends is 1,000 minus X divided by 5. Distance divided by speed. So I'm going to come back to this question. The cost. You see the other question we divided? Here I'm going to multiply because the cost is distance times cost per meter. That's the distance in the water. $5 per meter, so it's 5 multiplied. So I'm showing how in this question we multiplied by that number, and in that question we divided by the number, because speed is distance over time and cost is distance times cost per meter, and plus 3 times 1,000 minus speed. It's $3 for that distance. And now I've set up the equations for both. Now I will come back to this question. We do the derivative to find the minimum. We bring that half down, subtract a half, times 2x, that's chain rule. 1,000 over 5 is 200. When we do the derivative, it disappears. Minus x over 5 is minus a fifth x. The derivative is minus 1/5. That's the derivative. Set it equal to 0. And I make that a fraction. Minus a half on top is a half at the bottom. There's minus 5. When I set it equal to 0, it's like, instead of saying minus a fifth equals 0, I'd say equals a fifth. We cross multiplied. And because there's a root sign, if I square each side, it does away with the root sign. So it's 9 times the bracket, 25x squared. And now I'm simplifying. One method I could divide each side by 9, but I multiplied out 9x squared plus 90,000 and I subtract 9x squared from each side. 16x squared equals 90,000. X squared is 90,000 over 16. And x equals the roots of numerator and denominator, 300 over 4, which equals 75. And of course, the other option is I rooted each side. 4x equals 300, x equals 75. X is 75. That point up there is 75 meters along the other side of the pool. That's answered the question. From there to there, x is 75. That minimizes time. Now we come back to cost. That was our equation which we had, which is distance times cost per meter. We do the derivative. That half comes here, so it becomes 5 over 2. Chain rule, there's a 2p over here, and that 3,000 disappears, minus 3. Now we just simplified into a fraction, like the bracket to the minus a half becomes a half at the bottom, and those 2's cancel, that 2p on top and the 2 at the bottom, so it leaves 5p on top, and minus 3 equals 0. If we set it equal to 0, minus 3 becomes 3 on the other side, and now we cross multiply. 5p equals 3 times p squared plus 10,000 to the half, and I should have brought it closer together, and because I have a root sign, it's easy to square everything. The right becomes 9 times bracket. If I square it, left becomes 25p squared. I multiply out the bracket, 9p squared plus 90,000. Subtract 9p squared from each side, 16p squared equals 90,000. P squared equals 90,000 divided by 16. What I do to the left, I do to the right. And 90,000 over 16 is 5625 with the calculator. If p squared is 5,625, p equals 75. I wrote that 16 by mistake. If you take out a calculator, it's equal, p equals 75. So it's 75 meters from the end. The electrical wire to minimum price is 75 meters from this corner. By absolute chance, coincidence, we got the same answer in both questions. It equals 75. So the reason why I did both questions to demonstrate the fact that in one question I divided by that 3 and the other one I multiplied, because it's cost times distance per meter and speed is distance divided by time. And there's my diagram for the speed, and that's my diagram for calculating for the wire. So I hope you understood my two questions.